All right, good afternoon, everyone. Thank you so much for attending today. I should preface by saying, so first, my name is Natalie Nelson. I'm an assistant professor in the Biological and Agricultural Engineering Department at NC State, and I am not going to be giving a 1.5-hour talk today. I think from the program, it might not be crystal clear what this is. So this is a moderated panel discussion, and we have an excellent slate of panelists here. You won't be hearing from me much. I'm just going to help with the Q&A afterwards. So I'm going to go ahead and now pass it off to both Megan Carr and Thomas Thelen, who are PhD students at NC State, who had coordinated the panel today, and they will be the ones running the rest of the session. So thanks again for attending.
Thanks, Natalie, and welcome everybody. We are, I think, in the last session before the poster and reception this evening. So please join us. It's 90 minutes. And if, of course, you guys need to come in and out as you need, totally welcome and understandable. Okay, so the panel motivation for today is our coastal communities are beginning to flood from sea level rise, and we call this type of flooding chronic flooding. You'll also hear it as sunny day flooding, high tide flooding, lunar flooding. We're still trying to figure out the exact name which describes this phenomena. But the numbers are undeniable. By 2050, the models, and specifically we're using data from NOAA's 2022 high tide flooding outlook, our coastal communities, and this is a statewide statistic, so we compiled data, just the numbers from Beaufort, Ocracoke, Wilmington, and I believe Duck. And so these communities are expected to have 1 to 1.75 feet above the average sea level in 2000, and this equates to 40 to 155 days of high tide flooding that we're going to expect in the next 30 years. So in this moderated panel discussion today, we want to explore what can be done in the near term, so now and the years following now, to monitor and acquire data to assess sea level rise impacts. So we have 5 wonderful panelists. We have Dr. Katherine Anarde, Dr. Miyuki Hino, Dan Tomczak, Savannah Newbern, and also we have a virtual panelist, Ian Conery, whom you'll see once we have this slide over. And so today our panel format, it's a 90-minute session running from 3:15 to 4:45. And we'll begin with this introduction, and then we'll have short presentations by the panelists and then the Q&A session. And so during the Q&A session, we ask that first questions are given in the microphone, so our Zoom audience are able to hear our questions. And we'll open up questions at the start of the Q&A session. So during the presentations by our panelists, we ask that you write down questions to ask later. But in that Q&A session, we'll kick it off with questions, and you're welcome to, at any time when prompted, ask your question as well. And for our virtual attendees, we ask you to submit your questions via Zoom, which we'll monitor throughout this session. Thank you, and I'll pass it to Thomas.
All right, thank you for that introduction, Megan. Our first speakers today are Dr. Katherine Anarde. She is an assistant professor at the NC State Department of Civil, Construction, and Environmental Engineering, and Dr. Miyuki Hino, who is an assistant professor in the Department of City and Regional Planning at UNC Chapel Hill. They are both co-PIs on the Sunny Day Flooding Project, which they will tell you a little bit more about right now.
Okay, so we are going to have a joint presentation today. I'm Katherine, this is Miyuki. I am an engineer, so I want to put a plot to some of the statistics that Megan brought up on a previous slide. So here I'm showing sea level change over time, starting in the 1970s, extending to the modern in 2020. These are measurements from tide gauges in black, satellite altimetry in blue, and then all of these colored lines are the future projections for different emission scenarios. So what we can see from this plot is over the last 50 years, we have experienced in the Southeast region about 0.2 meters of sea level rise. But for the next 30 years, we're expected to see almost double that amount. And with this change in sea level, we are going to experience an increase in flood frequency. But coastal communities are already experiencing these floods. So what I'm showing here is a GIF or GIF, however you say it, of flooding coming up through a stormwater network, up out onto a roadway, onto sidewalks, and into a business in Beaufort, North Carolina. This GIF was collected or was created using images from one of our sensors that I'm going to tell you about in a couple slides. So communities across North Carolina are experiencing flooding outside of extreme events. We've talked about this already in several sessions today. So how do we estimate how many of these floods are happening both now and into the future? Well, we rely on tide gauges. Tide gauges are located in open water bodies. Here in the schematic, I'm showing a tide gauge over a bay. It's measuring the water level in the bay during a flood. In this schematic, the flood is the result of water coming up through a stormwater network or overtopping low-lying shorelines. And this results in flooding in a roadway. So we use historical data from tide gauges to develop thresholds, proxies for flooding on land. And with these proxies, we can count the number of days per year currently that communities might be experiencing high tide flood events and may into the future experience high tide flood events with different scenarios of sea level rise. So in this example, I'm showing the number of days per year on the y-axis from 2020 up to 2100 for different scenarios of sea level rise for the tide gauge in Beaufort, North Carolina. So in 2020, using these flood proxies, there are just a handful of estimated floods. But by 2100 for the low emission scenarios, Beaufort may experience up to 200. And on the high end, be flooded every day. So this is a metric that we use to estimate, again, the number of days that a community or a region might experience flooding by tides due to sea level rise. So these thresholds, these proxies are provided, or they were developed to provide a more consistent national coastal flood metric, but they were not intended to supplant knowledge of local flood risk. They were not created to actually indicate the floods that are causing disruptions in coastal communities. And that's because tide gauges are not intended to capture all sources of flooding. They're intended to measure water levels and water bodies. So here's the same schematic where a tide gauge might measure the water level shown here, which is below the flood threshold. But in the community, if there's rainfall or if there's elevated groundwater levels, they might be experiencing a flood that is not identified at the tide gauge. So what we've been doing as part of the Sunny Day Flood Project is trying to instrument stormwater networks across the state to measure floods on land and what's actually driving the floods on land. What are tide gauges not able to capture? So the name of our sensors are the Sunny Day flood sensors. They consist of a pressure logger that is deployed at the bottom of a storm drain. That data is relayed in real time through a communications gateway that also contains a roadway camera. So we can use this sensor not only to get a count of the number of floods that flood the road, or the number of times the roadway is flooded, but also serve as a means of communicating the hazard to the community. So these Sunny Day flood sensors can detect these bay or sea driven floods. So water coming up through networks, or overtopping bulkheads, and they can also detect these rainy day floods or compound events. We've deployed these sensors across the state. That GIF that I showed you was from a sensor located in Beaufort. We also have sensors in Carolina Beach and in Newbern. So here is another sensor in Carolina Beach. This is my PhD student, Thomas. Here's the pressure logger that is tied to the bottom of the storm grate, and then the communications gateway on the top.
Okay, so I'll just walk through a really quick snapshot of some of our results. What you're looking at here is data that we've collected in Beaufort. This is from June to November of 2021, so it's about 5 months of data. And what you're seeing in black is the cross-section of the roadway. So the two high sides of it are the sidewalk, and then you have the storm drains, which are the little dips, and then the roadway is sort of curved across the middle. Every line that runs across is an instance where we measured water above the on the roadway. And so they're colored based on if it was a sunny day event, meaning there was no contribution from rainfall, or in the pinkish color if it was a rainy day event. So it was a combination event. Over this 5-month period, we detected 24 flood events. They're all shown here. Based on the NOAA high tide flooding threshold, which would capture only the sunny day events above that dashed line, they would have reported 4. And the other dark dashed line that you can see there is the National Weather Service threshold. This is a different operational threshold used for issuing warnings. And that would have been triggered 8 times. So a quarter of the events that we have seen over just this 5-month period were driven at least in part by rain and wouldn't have been captured by other sources. With our community partners in these 3 different towns in North Carolina, we're trying to work with them to think about how the different drivers of flooding might inform the solutions that they choose to pursue. For example, raising bulkhead heights or seawalls or the elevation of that edge along the coast often seems to be an attractive solution. But if a lot of your flooding is coming from rain, then that actually is not going to be all that effective in mitigating your flood frequency. There's a lot of other things that these our community partners are considering, everything from higher roads to restoring wetlands, thinking about pumps and drainage infrastructure and how all of that works together to manage the flow of water. And by working with them to think about what are the drivers of the flooding that they're seeing and how do each of these different interventions change that flood frequency, we're hoping that they can develop solutions that are effective in the long term, not just what they're currently seeing in current sea levels. So what we've seen so far, we can see that land-based measurements. So in our case, what we're monitoring in the storm drains, they're needed to capture floods from multiple sources. In Beaufort and in the other places that we're working, using the tide gauge data as proxies for flooding is an underestimate of actual flood frequency. And that's partly due to the contributions of rain that aren't getting picked up in tide gauges. Lastly, we think that understanding the drivers of flooding can inform the development of longer term, more sustainable flood mitigation solutions. This work is ongoing. It's been supported by Sea Grant, by NSF, and by the DEEP project, which Elizabeth Frankenberg spoke about this morning. And what we're working on moving forward is translating these flood measurements into estimates of community and household impacts. So in this animation, in the yellow little rectangle on the bottom, you can see trash and recycling bins getting lifted up and floating away down the street. This is in Carolina Beach. And in the blue square in the middle near the top, there is a car that tries to drive through the floodwaters, gets stalled, and then ultimately has to be towed away. So we know that these events are disruptive. And what we're working on now is linking the data that we're seeing from our storm drain sensors and our cameras to the experiences of people and communities and businesses that are affected by them. All of our data, our depth measurements, our pictures are being streamed in real time And so if you're ever curious if it's flooding in a place that you care about, or if you just want to see what's going on, you can go to this website, you can scan the QR code. We have both the depth measurements, which is on the data tab, and the flood cams, which are just below it. And so we encourage you to check us out and tweet at us or send us an email. Thanks.
Yeah, I appreciate the opportunity for letting me join virtually. This has been super interesting so far. And I think, I'll try to present some of what, the perspective from the federal government side of things. And, we are, as employees in the Outer Banks of North Carolina, we're also community members. So I have some of that perspective as well. I have a background in coastal geology and coastal resources management. And I've been working at the field research facility in Duck for a little over 3 years. Here's just an image of our facility. We have a very long research pier and an imaging tower and a bunch of gadgets I'll tell you a little bit about today. So I'll talk primarily about the citizen science Coast Snap initiative, but I wanted to give a little more context of what we do. That's also related to this session. So I've done a lot of work with more sort of traditional beach monitoring, and sort of the theme of today will be shorelines. And shorelines are, of course, sort of our primary metric when looking at coastal change. And shorelines, of course, are impacted by sea level rise, and we need to ultimately have better data sets that can help us predict, what our shorelines will do under different sea level rise scenarios. So I've done a lot of work in the past. You can see this outfitted van. It has a laser scanner on it, so we can drive the beach and construct these 3-dimensional models of the whole beach and dune itself to see how it's changing with storms and different nourishment projects, things like that. And you can ultimately develop, a set of these colored profiles show, a bunch of surveys through time, and we can look at managed versus non-managed areas. And so these are, some of our traditional methods. We're also moving into more lightweight systems, some robots. You can see in this image to the bottom right. So those can actually drive, out into and survey our seafloor. And then we're also using a lot of drones for images, but also for, LiDAR and several other things. So in addition to sort of those typical, beach monitoring, we are also interested in understanding the sedimentology. So what do I mean by that? We want to understand the specific characteristics of the grains. As you can imagine, a large sand grain is going to move way differently than a smaller sand grain. So that's something when we're trying to predict these processes, a lot of times we assume, a uniform sort of sand grain. So you might not think, but it's important to collect this information too. So we do that both on the coastline, but also in the water when we can use these amphibious vessels. Here's the Lark shown in the top left. And I just wanted to, for the sake of this session, I wanted to highlight some of the work of some others in our lab with the citizen science program called SandSnap. And so they're trying to collect these samples across the nation, and you can submit your image and give them helpful data. So this is important to also track, in light of sea level rise and climate change. That is called SandSnap. Moving a little farther away, you might not think, but we are using satellites a lot now. Technology is rapidly improved with satellites, and so we've been working with a tool called CoastSat. That's from the University of New South Wales in Australia, and so these satellites present a free data source, and they're improving in resolution. And it's really cool to have an image of a site maybe you're interested in every 5 to 16 days. Of course, they do have some error, but through the air, you can start to piece together decadal trends or storm impacts. And so this is something we're pursuing, and we're trying to make a user-friendly tool to be able to capitalize on this data set. So moving into more traditional coastal imaging. We have in the back or in over the course of the history at the field research facility, we have conducted a variety of imagery monitoring studies. They might include something as elaborate as installing cameras on the roof of a hotel here to get really high fidelity imaging products. Now we're looking into lower cost options, even trail cams that hunters might use. And then our lowest tier, tier 3, is using cell phones to capture shoreline changes. That's called CoSnap. And so all these, no matter what method it was, we sort of realized we needed to take a step back. And as related to this session, one of the major challenges in these different imaging techniques is bringing in a lot of data. So once we started to expand, we were realizing we were having trouble ingesting and storing the data, processing it in sort of a timely manner, and then sharing it to the public. So we've realized we need to sort of compile these all together, and we've taken a lot of steps to improve this process. So we're hoping to have a nice web viewer here within the next couple of years. So if we take a little closer look at the citizen science effort, as I mentioned, this was created in Australia. It's been very neat to see it expand across the world. I think this is even a little out of date, but the last I had checked, there were over 130 stations in 16 countries, and you can see some of these examples here, capturing changes in shoreline at many different settings. We were the first location in the US, and we've since expanded into the Southeast. And this technology is really simple. All it requires is a hardened camera mount where you scan a QR code at these signs, and it takes you to our sort of landing page, and you can submit a photo. And so for every submitted photo, we can automatically extract the position of the shoreline. And so that what does that give us? That's going to show us maybe how our shoreline responded to a storm, how it's responding long term to maybe a nourishment. So we can do quite a bit with just a cell phone image, and everyone nowadays has a cell phone. So we're learning more and more how to best streamline this sort of process, and helping. We're partnering with people and communities to help install these stations. You can see some of them are quite popular. We at Jeanette's Pier, we get over 130 submissions per month. So it's been pretty encouraging to see the response to this. Just some quick examples of the CoSnap products. So again, you have an image or a shoreline for every image submitted. So on the left, we can see 30 meters of erosion from a storm. We can also monitor how that beach is recovering following the storm. And then if we look at sort of a longer time period, you can see the colors going from blue to red, showing from early to late. You can see this longer term trend at our site here in Nags Head. So you can start to understand maybe your seasonality or longer term evolution. And so again, this is a free data source that happens to also be quite accurate. And so here's an example just of one of our reports. We wanted to see, before we expand, we wanted to make sure this is accurately capturing the coastline, and we compared it to that van-based LiDAR, and that's what you can see on the blue versus the red line here, that these cell phones are capturing a very similar trend to our much higher fidelity and more expensive methods that we've used in the past. So beyond just shorelines, I wanted to also include, there's much more qualitative information that you can, gather from an image. We can look at berm development or scarp development that impacts maybe, trafficability on your beach. You can look at different mineral types. You could look at your high water mark, which is great for, determining where areas have flooded the worst. Then you could also look at vegetation coverage in the dunes. So there's just a whole host of different things we can glean from these images submitted by citizen scientists. So just quickly in summary, a lot of it, I started showing our traditional methods. Those are great and accurate, but they require a lot of people and money to execute. So we're more and more exploring these remote sensing options for coastal monitoring, in addition to these citizen science initiatives. And they're surprisingly quite accurate, and compare pretty well with some of our more elaborate techniques. So we've taken a step back this year from the social media, but we're hoping to ramp that back up now after sorting through some permissions issues. So you can follow along at CoSnap USA-SE. That stands for Southeast, and feel free to reach out by email as well. So with that, I will stop sharing and pass it back over. Thanks again.
Hello, great presentations, everyone. My question was related to using citizen science. So a lot of the citizen science was shown to increase and improve our understanding of these systems scientifically, but how does using citizen science engage community members, and how does that improve your science overall?
Yeah, Ian, online, would you be willing to take that question?
Sure, yeah. So I might need to just recap. My audio is cutting out there a little bit. I think how are we benefiting from citizen science, or how is it sort of adding to our capabilities? Was that essentially the question?
The question was more specifically, how does citizen science improve community engagement? So
Okay.
everyone seemed to talk about how citizen science can improve, or several people talked about how citizen science can improve our understanding of these systems scientifically, but I was wondering how it can improve community engagement and like community understanding of sea level rise and other environmental hazards.
Sure, yeah. So I'll start just by acknowledging for us, we've sort of in the past felt a bit insulated, and not felt like we're sharing our data with the public enough, or really engaging. And so this has been a unique opportunity to where it's first a great tool for us, right? It's a quantitative data tool, but we've also really learned a lot from various outreach efforts, and we've realized that if you have a platform like this, you can really get people interested in understanding their coastline, and if they're interested in understanding it, I think it's overall going to benefit our community as we understand how to design projects and manage our coastlines. So yeah, it's not just a great data tool, but it's also, I think, important in bringing together the scientists and engineers and community members.
I'll add to what Ian said, and in regards to like the King Tides project, what we have seen is that the people within the communities are interested in. I mean, they live there, they see their flooded roads, during, sunny day events, not just during hurricanes. And so for them to walk down to their local pier and see the staff gauge set up with a little placard that talks about what the King Tides project is, it gets them they may not have heard about what the King Tides project was. But then they see that, and then they might read more about it. Part of the outreach for the King Tides project was to reach out to different groups within these communities that would be interested in not so much taking ownership of the staff gauge that's there, but to maybe take the lead in going down to collect data. And again, it just starts by, because I mean, in this respect, with the King Tides project, it's just it could be just be one person taking one data point per day. And but again, it all kind of leads to getting the community involved with what's going on, because again, the people in Carolina Beach, they see Canal Drive flooded as often as it is, and now they're coming out to the community meetings and to hear about what's going on and what's being done. So so again, I think it just helps to get the people in the coastal towns more involved with better understanding what's happening.
Thank you. These were awesome talks. Thank you guys. This is for the Currituck County Planner. Sorry, I forgot your name. Tell me again.
Savannah Newbern.
Savannah Newbern, that's right.
Yeah.
This kind of speaks to the same topic. Have you guys explored any kinds of public monuments or things you could scan with information that might help get the community behind you? Because I know that you said it's kind of slow. It's really hard to get policymakers to actually get involved with this very serious, very looming issue. So things like this, yes, I would love to whip out my phone and then you start learning about it, it builds passion.
Yeah, I'm not sure that this is on, but I could speak to something that a neighboring county is doing. Dare County has installed these really beautiful and colorful storm surge poles, which give a physical representative of what that flooding would look like in person if it was right there next to you at a human scale. And I think that this has been really impactful to the community. People take photos with it. And I think something like this can be implemented similarly and would help draw the community's attention more. Yeah.
Thank you.
I had a question about the sunny day flooding. So part of, what you're looking to do is identify or improve some of the National Weather Service thresholds for flooding. And it sounded like rain was a big part of that. And so do you plan in terms of data needs on installing MET sensors as part of the packages that you have in the stormwater outfalls with the cameras, or is that important?
So we are trying to fill data gaps to enhance the estimates of flooding, not necessarily improve the thresholds by the NWS or NOAA. Just to clarify that we're filling a different need with this data. But in terms of deploying meteorological gauges, what we're trying to do right now is actually pull from other sources, publicly available sources, to see if instead of deploying sensors everywhere, which isn't feasible, we can't work in every community or we can't put sensors in every storm drain. Can we eventually use remote sensing, meteorological gauges, and try to relate those measures to drivers in different communities? So in Beaufort, we're looking at precipitation gauges at the airport and seeing how good those measures are at predicting with machine learning techniques what's actually going on the roadway. And so far, we just don't have enough data. So in a year, maybe I can tell you more. In Carolina Beach, there's a MET gauge. And some of the other communities we're working in, the gauges are more remote. So I imagine it's going to be much more challenging to relate that information to locally what's going on.
I really enjoyed your presentations. I had a question about the sunny day flooding also. Do you have any sense for how far inland, like you see that type of impact? How connected is the storm drain network, like along the coastal waterways? Like how far, is there any sense of how far inland that influence extends? Is it just kind of proximal to, waterways, or does it extend pretty far inland? I guess it probably varies, but just kind of want to get a sense.
Take it again. Okay. It depends on the community. The question of spatial extent is really challenging, and these floods are hyper local. They depend on the elevation of the outfalls, the elevation of the roadways, the surrounding land. So in terms of how far inland water can extend within a given community, it's a big question mark. And within our collective groups, Natalie and I are working on some low-cost cameras that we can put all around communities that can detect if there's flooding in an image while preserving privacy. So we're trying a bunch of different scientific techniques to try to get the extent of these floods, but it could be a couple blocks in low-lying areas like down east. It could be extensive marsh areas and farmlands. In terms of the whole North Carolina coast, sea level rise impacts are felt really far inland. So Newbern is experiencing chronic flooding by sea level rise. So spatial extent is relative.
So a lot of what you guys have presented today has been really compelling. And I was wondering, is there a chance if you had a chance to present it to local decision makers or elected officials? And if you have, how did you find, would they respond more to like the data or the imagery, or what kind of worked the best?
Sure. We have the communities that we've been working in have been really supportive. They've helped us. They know that this is a problem. They've been enthusiastic. They've helped us get power onto certain poles and all sorts of stuff. So they've been really helpful. I think the question of like what they need, what they find compelling, they're all in kind of different places in the maybe what you can think of as like an adaptation pathway or adaptation progress. And so in some places, I think they are just like trying to get a handle on what's going on. And so in that case, just getting a sense of frequency and kind of raw measures that way can be helpful. In other instances, I mean, they have solutions in mind. And so they're receptive, but they really want to know, I would say like more sophisticated. They're not surprised at all when we show them the data, and they actually want us to go farther with it. So I think in general, it's been quite receptive. Obviously they want solutions, and we can't really tell them we have solutions. But it's been different in every case, kind of what's been more useful to the decision makers.
Can I add to that? Just to provide a specific example, in Carolina Beach, they have duckbills on their outfalls. And so one of their questions was, are they working? And so the town is interested in the pressure sensor data, but the images from the cameras are useful for shutting down the roads by the police. So that was cool to see dual utility from different avenues in the community within one sensor. Your perspective on that?
So I think your question spoke to what was compelling, specifically data or imagery. And I think oftentimes in municipal planning or county planning, it's very valuable to capitalize on moments of community interest. And like immediately post-storm, there's often a lot of folks who are really engaged and interested in how they can see their community better protected for their next storm. And it's often at these moments where the recent damage is still fresh in their memory. And we have some policy options that we can present to them that we can see some progress. I think, yes, specifically post-disaster response is when it's most compelling to act.
Presentations, everybody. Just kind of a couple comments, kind of doubling down on the question about precipitation. What's interesting about using the airport, you could have days in the summer where the precipitation patterns kind of all over the map. But what I was thinking, you could, obviously there's the feasibility of not being able to provide, all the instrumentation at every site, but you could double down on the citizen science. There's a program called COCORAS where if we had an observer that was willing, they go out and take measurements. We could put a COCORAS gauge right where the camera is. You'd have citizen science involved in both programs. And then we could almost get an ambassador out of that from the Weather Service at the same time. At the same time, you could use, I love the remote sensing idea. There are some limitations with that, and you can use the COCORAS data to kind of gauge correct what's happening from the satellite or what's there. So there's a lot of different ways to combine this, but I love all this citizen science because, I think we're at a point where maybe there's some erosion in trust in the scientific field. And the more that we get people involved in these projects, I think the more we're going to be able to combat that. So I just love everything that all of you presented.
COCORAS, is that COCORAS? Yeah. Okay. Thank you. Gnarly ideas.
And if I could ask a follow-up related to that, so there's been a lot of discussion about then these types of community engaged science programs and data collection. And Savannah, you had also mentioned that in some cases, private landowners are collecting data on their own. So I'm curious then, is this what you all view as the solution then to filling information gaps? Is this going to be the primary way that information gaps are filled, is through everyday people collecting this information? Or do you think that there is going to be maybe advances in what government is collecting otherwise?
I think that this is it's gonna help know where this leads to. Some of the questions that I've been asked in other presentations is how do you calibrate the data that people are submitting, and again, for the King Tides project, we have these staff gauges, and if someone goes out to the staff gauge and they read 21.5 and maybe it was 21.7, is that going to be a big deal in the end? I mean, again, the big thing is just trying to get these programs to get the citizens more involved with understanding what's going on, and such something as straightforward as just kind of taking a reading off of a staff gauge. Well, I say it's straightforward, but again, it's just something that I think that the citizens want to do. Will it be able to fill in all the data gaps? I think it'll help a lot in helping to fill in where we just don't have in these smaller communities where we don't have a NOAA gauge or a USGS gauge that's available. That if there's it could be a low-cost sensor that's installed along a dock, or it could just be a simple staff gauge. But it's a means to help be able to collect additional data. Now, who's going to compile all this data? I guess that's a whole nother discussion. But again, it's something that I think that will help be able to fill in the gaps.
Ian, I would love to hear your thoughts on that as well. Where do you think this community-based data fits in next to some of the more high-tech data that you guys are collecting out of the FRF?
Yeah, sure. I'd love to add to what was already said there. We've discovered that data is so sparse, both in space and time, And, you know, we're trying to help our different district offices, you know, make, you know, data-driven decisions, right? And often because of, you know, the personnel required and the costs required to monitor stretches of coastline, they really don't have much real data to base their, you know, project design on, or, you know, even storm impact. So there are places, you know, where we'll have maybe a survey per year along a beach, but adding in, you know, a camera station that uses these cell phone images, you can have images like I showed daily. So it's not sort of the golden solution to all of our problems, but it really can help enhance, you know, what data we have at our fingertips, while also sort of engaging the public. So that you know, citizen science coupled with, as I mentioned, remote sensing, where we're using satellites or things that we don't have to maintain individually, I think that will, you know, help us in the long run tremendously.
I just want to add one thought to that. We know that the places where we do have a lot of monitoring and sensing stations are not randomly distributed. They tend to be in urban areas. They tend to be in wealthier areas. And so the places where we have data gaps are also not randomly distributed, and they tend to be the places where people actually would benefit most from having the data and the resources associated with that. And so I think, of course, we want to do everything we can to fill those gaps, and engaging people and doing that where they live, where often they know better what's going on than any scientist does, is certainly like one way to do that. But I don't think that we should consider that to be solving the problem that we have not been paying sufficient attention to these communities to begin with. And so I think it's, on the one hand, there is great potential there, but we also need to address the underlying problem, which is that there are places that are flooding all the time that aren't in official flood hazard maps. And it's probably because we never collected data there, or have really poorly calibrated data there. And so if we're going to fix those problems, we shouldn't put the burden on the people who live there to do that.
Those are really good points. Thank you all. We have one question on Zoom that I want to get to. This question comes from Matt. How would you want to modify any of these monitoring approaches to better evaluate the effectiveness of sea level rise interventions? The example he gives is the outfall duckbill just mentioned. So maybe I'll pose that to Savannah and say, are there any of these approaches that you think could be more useful to solve issues that you're hearing about in your community? Or are there any that you think work particularly well, could work particularly well?
I don't think I understood the question from the beginning. Could you repeat it?
Sure. So how would you modify these monitoring approaches to better evaluate the effectiveness of adaptation interventions? So to make it more applicable to a project or a mitigation strategy that you would actually build out?
I think that these monitoring practices are extremely valuable and helpful and have a critical role to play in how we move forward. And that the main thing I would change is their accessibility and their availability and the funding that they receive.
That makes sense. Thank you.
Any other additions to that question? All right, fantastic. So Thomas and I have a question we've been burning to ask. So a lot of the projects which we heard about are kind of span multiple counties, multiple areas, and in some cases, other countries. So in thinking about various monitoring strategies, is it possible that there could be a one-size-fits-all solution in terms of the data that's collected at each municipality or county, or do counties need to have specific strategies that would work best for them? So kind of a unique solution for each.
That's a good question. I actually just brought up a similar question earlier. and again, I'll speak in regards to the King Tides project. What I've seen and what we've seen, that there are a number of King Tides projects around, the US and internationally. But they're not all, they're not all connected. There's not a central source where all of our photos are uploaded or where all the data is uploaded. I think each state does their own thing. North Carolina, we had the Flickr account first, and now we have this Coastal Observer app that we're using. South Carolina uses a MyCoast. I guess what I'm getting to is, unfortunately, we all have our own means to collect and store the data. I think what would be really good, at least in regards to the King Tides projects, because we're interested. It's like, okay, we see what's going on the coast of North Carolina, what's happening in Oregon, what's happening in Rhode Island, what's happening in Florida. And if there was a single source to go to where we could see what the citizen scientists in Oregon are posting, or what the citizen scientists in New Hampshire are posting, that'd be great. But right now there isn't. And so that's one thing, thing that we've sort of ran into is just, it would be good, again, it would be good to know what's happening in other states. So how do we fix that? I don't know. I guess it would be, someone to take over this. But again, it's really just kind of started as a citizen scientist project, for people to be able to upload photos of the flooding that's going on during these high tide events. But again, it would be a great, if they were all consolidated, it'd be a great resource of data for anyone who wanted to, know what's going on in North Carolina, in South Carolina, wherever. But again, right now, like I said, every state, and in some cases, like in Florida, I think it's like some counties have like a King Tides program, or city like Miami, the city of Miami has a King Tides program. So again, you have all these different groups or agencies, states that have their own program, but we're not connected. And I think if we were connected in some way, I think it would really be, again, I think it'd be a really great data resource for a lot of people.
I guess I will respond as a social scientist who has never sensed anything before, a couple years ago, teaming up with Katherine. I've never even thought about deploying sensors. It's been striking to me how different. So we have the same kind of core technology in all of our different communities, but the actual kind of deployment strategies and the questions they have all been different. And so, for example, in some places, like groundwater might be more of a concern in some places than others. Like active wetland restoration projects and the effectiveness of those, or the effectiveness of duckbills and so forth, are different questions. And therefore, I think we've been tweaking pretty consistently depending on where we are and what the questions, like what questions they want to answer and what environmental conditions really matter. And so it seems to me that in principle, the technology works, but the actual usefulness of that depends on the local conditions pretty strongly.
Answers.
Thank you all for that. So we're coming up on the end of the session here, and before we let everyone go, I want to give all of our panelists one last chance to either follow up on a thread where they feel like they want to add a little bit more, or give the audience a take-home message. So Ian, maybe we can start on line with you, and then we'll go to Savannah and go down the line with every panelist's closing remarks.
A lot of pressure to go first here.
Sorry about that.
That's okay. I think in line of the last question, yeah, I think, everywhere faces a unique set of challenges and maybe research questions. So I know from sort of the agency perspective, that's why we're really trying to make our technology adaptable and easy to transition to, a variety of users. We're trying to take things away from having to know how to code in Python to making it an easy to use tool. So I think, that sort of poses, a challenge to us as coastal practitioners and engineers and scientists. Let's make stuff that's easy to digest, and that way we'll be able to expand more rapidly and sustainably. I think, yeah, as community members, be aware and try to learn as much as you can about the environment around you. And as scientists, we need to have open ears and try to understand sort of the concerns and the questions of the people in the community where we're living. Yeah, happy to follow up on any of that. And again, thanks for the invitation here to participate.
Thanks so much, Savannah.
So following Ian and his valuable insight, as working so close to me right here at the Duck Pier, there's so many opportunities for collaboration and capitalizing on what is existing data. And it sounds like the work that's being done is very powerful and will be very effective as it's implemented throughout North Carolina. And, we might not have the resources to monitor and understand the impacts associated with exposure to accelerating rates of coastal flooding today, but we're growing, even if it's not every county every day across our coast and in coastal management. These strategies are being implemented, tested, figured out, and they will spread.
Yeah, again, kind of getting back to, using citizen scientists to help fill in the data gaps. I think it's a great resource. That there is the interest from the people living in the communities to better understand what's going on. And so I think, whether it's a simple staff gauge that's installed in the community, or a cradle to put your cell phone and take a photo from a pier, or a low cost sensor. I think the people are very interested in understanding what's going on. My sister is a park ranger down at Hammocks Beach State Park in Swansboro, and they just had a water sensor or a low cost gauge installed at the park. And she called me up and she was like giddy over being able to see, and it was just water level data that was being collected, but she was just giddy over the fact that she now has this this resource, at her fingertips, and she just pull it up on the computer and see what the water level is doing. So again, but it just kind of goes to show of the interest in the community to understand what's going on.
So my final thoughts from today, I'm thinking about the previous sessions that I've sat in and how we collect data, where we collect data, and how it impacts communities. So in thinking about near-term monitoring needs related to sea level rise, I think we need to reevaluate where we're collecting data on chronic flooding in the state, or just look at the maps. Where are the areas that don't have dots? Who lives in those areas? And how might that knowledge of flooding impact communities and capacity?
Yeah, I think from everything I've heard earlier today and I hear all the time, there's so much need. There are many, many places with people and things and lots of, things that we value and care about that are threatened. And there's, I think, a lot of opportunity for a partnership to put some of this science to use. Some of my research I think of as like not being particularly useful to people, but this is one of the rare places where I think we are at the cutting edge of what we know, and it can be used by people who need to make decisions about what they're going to do with their capital investment budget tomorrow and in 5 years and in 10 years. So to me, the takeaway is that there's a ton of need and there's also a ton of opportunity to put the science to good use.
Thank you all so much for sharing your perspectives with us this afternoon. It was really insightful, the talks and also the discussion. And so please join me in thanking our panelists. So that closes this panel. I hope you all had a great first day of the conference, and then I enjoy the reception this evening. Thanks.